Now, one can also say the fundamental block of wireless structural health monitoring is a low cost sensing unit. For example, using wireless telemetry, that is wireless radios, and mobile computing, that is using embedded microcontrollers, the communication and processing have become very cost effective. Most importantly, sensors of the modern type has the capacity to take self responsibility of their own measured data. So, the blame game of packet loss, wrong data, wrong interpretation has all stopped. Okay. Sensors have become more responsible these days. To say so, there are sensors which has multifunctional materials. Which uses piezoresistivity, in single walled carbon nanotubes, that is single walled carbon nanotubes has a new dimension for strain sensing. The carbon nanotubes has an alternate and attractive solution. Of embedded sensors in composites. So, the advantage of this could be they have additional resisting strength and as well as they have high sensing capabilities and adaptive system, which is one of the major identification technique used in modern SHM, is a great advantage. Now, these have data compression technique, which makes the data compact, safe, password protected and also reliable. There are sensors which can measure damage even at a very low scale and in the long term deterioration. Further, fault detection and control offers the ability to control systems which is designed with an integrated hardware of sensors with high reliability. Further, in post processing of the data, finite element model updates plays a very important role. It is important and necessary to choose a proper FEM model to simulate the damage, what we call as postulated failure, and then form a benchmark value for the control strategies. The next issue which is also advanced is the sensor placing technology. This ensures uniform distribution of sensors, or I should say at least uniform distribution of measurement. It also ensures low cost and compatibility. The recent advancement in US which is a combination of natural excitation technique which is called as next with eigen system realization algorithm, which is ERA, is one of the recent features to carry out damage detection under dynamic excitations. However, very interestingly, a common problem which is generally argued upon for the unsuccessfulness of SHM is the effect of environmental conditions on sensor performance. Even this issue is answered. People have started using principal component analysis, which is PCA, which is a multivariate statistical model that can reduce the effect of environmental factors such as humidity, temperature, etc. on the sensor performance. The next challenge could be large size of the infrastructure. Let us say long bridges, tunnels, etc. Now, this can be also answered by using distributed health monitoring system, which can be used to measure excessive strain, deflections and load distributions caused due to temperature variation, settlement of foundation, etc. on the structures on a long term basis. So, friends, we have discussed the whole course, lecture spread in 4 modules. We talked about the basics of structural health monitoring, sensor technologies, then the method measurements, lab scale applications, real time issues of the health monitoring scheme, then integrating health monitoring with alert monitoring to manage the disaster prevention. We have also discussed various sensor specifications, layout style, sensor type applied to both wired and wireless, and we have discussed about the advantages of wireless sensor networking after validating the WSN with wired sensors. I hope you have understood and enjoyed all the set of lectures in 4 modules, with which we will be completing this course with this particular lecture in 4th module. Each module has been submitted with lot of tutorials exercises for your betterment and understanding. Kindly post your queries and informations required for more learning through announcement forum, discussion forum in the portal of NPTEL IIT Madras. I will personally attend to these questions and try to answer them with my interactive team, which are completely working dedicatedly on health monitoring systems, especially on a lab scale, and a few attempts are also made to apply them on a real time monitoring scale. Thank you again, and thank you for your consistent support and attending all the lectures and participating in all tutorials and enjoying the coursework which we did through this particular structural health monitoring course at NPTEL IIT Madras. All your queries can be posted to drsekaran@iitm.ac.in, which is my email ID at IIT Madras. I will be personally attending to all the questions back along with my team and try to support you literally and completely through and through for your tutorials and for the entire course. Do help and entertain your friends and consulting engineers to pass on the benefit of these course contents to all of them, and try to write to me personally any improvement required on the course content, any update required, which I will do that certainly the next cycle. Thank you very much and bye.